want to make a sincere statement. My purpose here is to acknowledge Michael as someone who has made an enormous difference to his field and an enormous difference to a lot of individual people. That's not easy to do, and I congratulate him on his ability to stick to his guns, to work against the kind of issues we've just heard about, at a time when it's been very unpopular to do so. And for many of us, Matthias, Yu Hong, you heard from them very clearly this week why it was so important that they be protected as young scientists, as an institution that tries to force you along a path when we don't know what the path will be. Otherwise, we wouldn't be doing research. What's the point of doing research if we already know the answer? So anyway, first I would like to say this is perhaps the most stimulating meeting I've attended in my life. I'm 60. I hope to retire fairly soon, like Michael. And I would think that in all these years, I remember going to a first meeting in 1981. When I first started as a graduate student, there was a guy called Philip, showed up as a postdoc. He was supposed to go to a meeting, so they sent another Philip instead because he didn't show up. And there I met two characters who scared the hell out of me. One was Richard Thomas, who was associated with HAO, and the other was his female counterpart. What was her name, Tom? Do you remember? No? Anyway, there was this pair of people. The first talk was given by a member of Carol Jordan's group that I came from at Oxford, and he was just shredded by Dick Thomas. I mean, it was one of the most enlightening things I'd ever seen. Thankfully, this meeting is not like that. And the reason it's not is because of Michael's breadth of inquiry, his willingness to look at inside an institution that has a mission, nevertheless, do the things that he believed in. And I believe he's been very successful, as I'll try to show you. So I won't keep you very long. And I don't know if we have the lights down. Do I do that? I couldn't actually read these things. Okay, it's okay. So what is this? What am I showing here? I'm putting Michael in context, and Michael is that arrow. And he's progressing onwards into the future. And it roughly spans the time that he was director of HAO. Now, I've got two plots. One is the cumulative number of PhD theses that I could find on the NASA ads in solar physics. I started after the Second World War because before then, after all, we didn't really have funding for research at universities like we do these days. And here's the number of solar PhD theses as a function of time. I was surprised by this because there will be a bias, and the bias will be towards more modern theses because they tend to get submitted to the NASA ads. So this is a representative thing. But I find it very, very interesting to see, also at the top, the history of what was going on. First of all, NASA began in late 1950s. Kennedy made his statement in the early 60s. ESRO was formed, later became DISA much later. Cray 1 computer appeared, 1975. VAX computers appeared, multi-user things that were friendly, and you had to sit and wait for your job to run with 30 others for hours and hours and hours. There's the chipsets. Here we have the beginning of the internet here, and what else do I have? The Berlin Wall fell here. Make of it what you will, but I found this, I thought when I built this because I was starting to write a paper on methodology in solar physics. I haven't had the time to do that. I might do it after I retire. The middle line shows the space missions, and the upper line shows the ground-based missions. You can call them missions, ground-based telescopes. Most notably, I want to point out this one here. The Dunn Solar Telescope, 1969, was the very last facility instrument for solar physics on the ground in the United States, 1969. That arrow points a direction towards, and I haven't even included here DKIST, but I believe at the beginning of the meeting here this week, we heard from the Phil Goody's Solar Telescope. We didn't hear much from the Swedish Solar Telescope, but we heard from these new facilities. Michael has been behind the scenes working for these things. And I don't think it's a coincidence that we've moved from the sub-meter scale observatories to the much bigger ones as time has gone on. And if you look at these, you can wonder whether there's incremental work or not. I disagree with that. In 2000, it was called the Parker Report, wasn't it, that you worked on? Or is that a different one? Okay. So, but there were examinations of what we should do next, and somebody decided to build a freaking huge solar telescope. And so we heard about what DKIST will do. And I know that Michael, as a PI on one of the instruments, worked very hard to secure the funding for the first time in 5 decades. This is an amazing thing. Neil Armstrong was on the moon the last time they built a facility instrument for solar physics. And now we're so looking forward. And I think the conclusion of all this graph must be, we're in a healthy state with PhDs. It clearly was, solar physics has benefited from the space program. I think solar physics is going to benefit enormously. And I don't know whether we'll see a growth there. But to a large extent, it's people like Michael, Gene Parker, and those others working so hard behind the scenes to allow young people, I can see several here, we've got postdocs, students around, in the next 50 years to take advantage of what is a real breakthrough. And I'll talk about why I think DKIST kind of things will be a breakthrough. Now, so that set the scene. My reading of this meeting is that we have still the major questions in solar physics, and I don't even include coronal heating. That's of almost no interest to me anymore. I figured it's almost impossible to do anything with it. So anyway, so here are some of the major questions. And I want to start, the things in red are quotes from the meeting. We have a convective conundrum. This is astonishing. It is just astonishing to me that we can't understand the hydrodynamics underneath the surface of the sun, confronted by helioseismology, in terms of a convective cell and its power, distribution of power with scale. This is a frightening, horrifying situation. What on earth is Betelgeuse doing? That is a fully convective star with maybe 2 or 3 cells on it. We've got a basic problem, apparently, in fluid dynamics in the interiors of rotating stars. Does it have to do with magnetism? Doesn't seem likely because there's not that much energy in the magnetism over a solar cycle. But nevertheless, there's a major problem. And here are some of the questions that go along with that. And I think the convective conundrum, which was so beautifully expressed, can address all of these puzzles. And the tools we have now to address these puzzles come from the work of people like Michael and many others in the space community. The other remarkable thing, and I'm quoting directly here, is that we still don't know how stars are formed. Now, I'm not equipped to say why that is, but we have one of the world experts sitting right here if you want to know more details about that. That's just a remarkable statement by itself. We've known we've had problems with things like redistribution of angular momentum as a disk form, et cetera, et cetera. We heard this wonderful talk this week. And then the other question is, I think it's still a fairly fascinating question to me, not necessarily a scientific question, but where is everyone? Fermi in 1950 asked this question. And I was struck by the fact that Guy claimed himself to be a terrestrial scientist, which begs the question, where are all the extraterrestrial scientists? It's certainly not sitting here. I mean, I think you could make a case that some solar physicists may look like an extraterrestrial or behave like one, but that's not true. Anyway, and then the other thing is we have this amazing big subject of astrobiology, which is a null subject. right? This is an example of the kind of thing that Michael has been advocating for years. It's a null subject because we don't have any evidence of astrobiology. We do, but it's not astro because if you look at the old system of the Earth and the sphere of the stars and planets and all this, it's terrestrial life. It's the only place we know about it. And life is everywhere on this planet that you can dig holes in deep as you want. You're going to find evidence of this stuff. So we have this null subject of astrobiology, which if you went to some politicians and said, what is astrobiology? They asked you what astrobiology is. And you say, what is the evidence for it? Well, there isn't any. But it's precisely that that's so important in science, is to ask these questions. And so we have this wonderful subject given to us for many years, and it's epitomized. I chose it because it epitomizes Michael's approach to science, I think. Now, Michael has been very influential, I think, in addressing some of these major problems. And I've put the convective conundrum up there. And so what have I listed there? Well, you could just read for yourself what's going on. You may not know what MURAM is, or you may not know what CSAC is. You probably know a little bit about machine learning. We have tools. We have observational tools. But we have this third pillar of science as one of Michael's protégés said, Mark Misch, unfortunately had to be let go as a result of cuts at NCAR. One of the broadest thinking physicists I've ever met. He working on radiation, I beg your pardon, on solar interior, hydrodynamical models. Now we're faced with this convective conundrum. We need someone like him to sit down and wonder what on earth is going on. And so HAO has been very carefully mentored by Michael, only to see some disastrous reductions in force afterwards. And this was interesting to hear from Travis in particular, as someone who suffered under that. I'm not going to comment on who, why, whatever, anything like this. All I'm going to say is that under Michael, I don't think that would have happened. And instead, we're following a strategic plan, we're ticking boxes, and we're counting publications. I'm worried about the future. The sun always seems to have planets, suns. Wherever they look, you get more and more of them. And if you compute the number of planets, there's a factor of 4,300 I missed on the front there. But if we extrapolate what you were saying earlier, you can compute how long it'll take before planets fill the whole universe, and the universe will collapse. Anyway, that's a remarkable thing. Look at that. This is a fantastic age for young people to go out and study the universe, study, if they want, life on other planets comparable to the ones we've just heard about. This whole discussion just now led beautifully by Guy. A fantastic opportunity, and yet here we are. The planets are over here, and here's NCAR. We're doing space weather, we're doing bang. Oops, just hit my head on something. This is a very, very serious problem, and I agree completely with Michael. Scientists need to take charge. I've tried to do this at HAO, and I've paid the price for it. It has materially damaged my career inside NCAR to argue for science. This is not acceptable to me. I won't go into it, but I will say I have firsthand experience of this. I want to contrast that with Michael's friendship of many years. I became very seriously ill. There was one time I remember where he said, Phil, your job is just to get well. That's it. Period. That kind of support is priceless. The support given to Matthias, to Yu Hong, manifestly shows up in the research we heard about here. Now, Matthias is at a point where he's got so many calculations all we're short of is manpower to examine these things. These are numerical experiments, just the same way as DKIST will provide observational experiments. And here we have an opportunity, and yet we are blinkered. I remember one time, Michael and I went out for dinner, and we must have looked like something out of a massive car accident, because I was wearing a full body thing like this after surgery on my back. Michael was struggling to get out of the car. And between us, I was sort of helping him like this. And then somebody came to help. It was a waitress in this restaurant who was about 5 feet and 85 pounds. So she was going to try and help me and Michael out. I mean, we must have looked like something out of a Keystone Cops movie or a Laurel and Hardy thing or something. But this sweet girl came out to try and help us, but we managed to get in there anyway. Those are the things that I really remember about what's so important. Here are some major tools that we have as a result. And at the bottom, I want to point out, I didn't mean this kind of tool. This is a quote, "We're like Trump, everything is about us." That's a totally different kind of tool I'm talking about. Politically incorrect as hell, but what the heck. Michael has materially changed the research landscape, and not many of us can hope to do this in our careers. And I want to thank him for doing that, because I have enjoyed the freedom as a scientist here. I've been encouraged to learn much more deeply very early on. It was painful to learn that I was doing irrelevant research, but I learned a lot from this, and I'm a much better scientist as a result. As a scientist and a leader, I'm just going to say some personal things here. You can read these things. I want to draw your attention to this kind of stuff here. And also, we heard so eloquently from these guys about what it meant to have Michael as a director at HAO. His kindness and protection of young scientists is second to none. We were defended against all comers from NCAR management. We didn't know anything about that as young scientists, and we shouldn't have done. And we should all be very grateful. And there's a small list of people. There are two Charbonneaus. One is Paul up in Canada, a famous numerical astrophysicist. And the other one we heard about earlier, David Charbonneau, who's Tim Brown once said, we'll all be doing what he wants us to do by the time he's finished his career. And that was when he was a first-year graduate student or something. Again, Michael allowed someone to come and work on a project ostensibly outside of all strategic plans. As a director, UCAR loves diversification. He did it well before UCAR really got interested in this stuff. You can just look at the track record. These are the things that I am totally grateful for. And one, I think a big statement about Michael is, I use the word grace, and I know that's associated with religious ideas, but what I mean is, he did such a graceful exit as director of HAO. Never once interfered with the direction HAO was going with other directors, as is only right. You could trust him to do that. But he showed such grace in doing so. He leads by example. As a person, and this is my last slide, he was a great friend in many times of trouble. I believe him to be a man worthy of emulation, whose life serves as an example. He's unselfish, he's stoic in the Roman, Greek, Greco-Roman tradition. Namely, rationality enters before emotion. Some people think this is a stale kind of thing, but he epitomizes, I think, what it is to be a modern scientist in a challenging place. And if it gives you any indication of not being a stiff, rational person, one of his favorite people is the English guy from Birmingham that you watch on TV. what's his name? Oliver. John Oliver. So, but that's because it's an intelligent thing, and that's part of the Stoicism. So the one thing I would like to make a tribute to Michael is just to see he has a passion had a passion as a young man for volleyball, and was almost professional, stand-up volleyball player, coached the university women's team. You know, it's sad that we see him like this, but this is not a sad man. This is a man who wears his tribulation like a rose, and I leave you to think about that.